Okay, guys, here is some extra practice for greatest common factor, least common multiple. This is just an example, and both this worksheet and the next one that we're going to be doing is going to be posted as well, so you can pull it up if you want to practice working them out also. Now, on this one, I went ahead and did it for you, but I'm going to walk you through it. It says there are 48 girls in choir and there are 64 boys in choir. The choir teacher plans to arrange the student in equal rows. Here's a key word. Only girls or only boys will be in each row. What is the greatest number of students that could be in each row? Well, because we're making equal rows and they want to know the greatest number of rows, it's automatically telling us that we've got to find the greatest common factor. So you're going to look at 48 and 64. And like I told you in class, you can do the prime factorization method if you want to make the trees, if that helps you. If not, just go ahead and list out all the factors. Obviously, 1 is going to be a factor of 48. 1 times any number is that number. 2 is also going to be a factor because 48 is even, so 2 times 24. If we add 4 plus 8, we get 12, so that tells us that 3 is going to be a factor, and if you have to, you can go out to the side and divide it and see that 3 times 16 gives you 48. 4 is also a factor, 4 times 12, and then 6 times 8. Since 7 is not a factor, we've hit a roadblock, and that tells us that all the factors are already listed. Well, it's the same thing with 64. 1 is going to be a factor. It's even, so 2 is going to be a factor. 3 is not a factor because 6 plus 4 is 10, and 10 is not a multiple of 3. But 4 is a factor. If you divide 4 into 64, you get 16. So there's 4 times 16. 5 is not a factor. 6 is not a factor. 7 is not a factor, but 8 is. And since it's 8 times 8, we've hit our roadblock. And that is all the factors that are of 64. Well, go through and circle. They have 1 and 1 in common. They have 2 and 2 in common. There is no 3 on the other side, but they do both have 4. They both have an 8, and they both have 16. Well, out of the ones that they have in common, 16 is the greatest. So that is going to be the greatest number of students that you can put on each row. Okay, so that's the number that they're looking for. All right, let's try this next one. All right, you ready? Okay, you have a bag with 30 fireballs and another bag with 42 Jolly Ranchers. For a party, you want to repackage. And again, remember we talked about it. If it's asking you to group things or package things out of 2 sets of numbers, you're always going to be doing the greatest common factors. All right, so we're going to package them into smaller bags, but you want each bag to have the same number of fireballs and the same number of Jolly Ranchers as all the other bags. And here again, what's the greatest number of bags that you'll be able to make? This one is going to go a step further and ask you how many fireballs and how many Jolly Ranchers are going to be in each bag. All right, so this is the first thing that we need to find, okay? Well, automatically, if we are looking for the greatest number, we're automatically looking for the greatest common factor, okay? And we have 30 and we have 42. Well, let's list our factors of 30. 1 is always a factor, times 30. 2, because it's even, and if we said 15 plus 15, that gives us 30, so 2 times 15. 3 is a factor, times 10. 4 is not, but 5 is, and it's 5 times 6. Well, instead of asking, is 6 a factor? It's already listed, so we can stop right there. We've made our U-turn, and we've listed all the factors of 30. Well, let's do the same thing for 42. 1 is a factor, times 42. It is even, so 2 is going to be a factor, and it'd be 2 times 21. Well, if we said 4 plus 2, that gives us 6. So that tells us 3 is a factor. Well, if we know 3 times 12 is 36, then 3 times 13 is going to be 39. That means 3 times 14 is going to give us 42. Then we ask, is 4 a factor? Well, no, because 4 times 10 is 40, and that doesn't give us enough room. 5 is not a factor. It doesn't end in a 0 or a 5. But 6 is a factor, and 6 times 7. Well, we're already to the other side, so there are all of our factors for 42. Well, let's ask ourselves, which ones do they have in common? They have 1 in common. They have 2 in common. They have 3 in common. There's not a 5 on the other side, but there is a 6. And then there are no other factors that they have in common. Out of these, 6 is our greatest number, so the greatest common factor is going to be 6. That means that's this number right here. That's the number of bags. Okay? That's the greatest number of bags. Well, now we have to figure out how many Fireballs and how many Jolly Ranchers. So we're going to put our parentheses. Okay? Here's our Fireballs, and here's our Jolly Ranchers. Okay? Well, how many Fireballs did we have? Well, if we look right here, it says 30. So we're going to put a 30 right here. And then we're going to ask ourselves, okay, so what times 6 will give us 30? Well, if we look back over here, oh, there it is. Look, 5. So 5 times 6 will give me 30. Well, how many Jolly Ranchers did we have? Look right there, 42. So we're going to put a 42 right here. And then ask, okay, well, what times 6 is going to give us 42? Oh, look, right there, 7. So if we make 6 party bags, okay, and we have 30 Fireballs and we have 42 Jolly Ranchers, that means we're going to lay out the 6 bags in the middle of the table. We're going to put all 30 Fireballs on one side, and we're going to put all 42 Jolly Ranchers on the other side. And we're going to go piece by piece. So we're going to take 1 Fireball and 2 Fireballs, then 3, then 4, then 5, then 6. And then we're going to start over. Bag 1, bag 2, bag 3, bag 4, bag 5, bag 6. Then we're going to start over. Bag 1, bag 2, bag 3, bag 4, bag 5, bag 6. And if we keep doing that till we use all 30 Fireballs, that'll put 5 Fireballs in each one of our bags. Well, if we did the same thing for the Jolly Ranchers, and we have 42 of them, and we said, okay, here's my Jolly Ranchers. Bag 1, bag 2, bag 3, bag 4, bag 5, bag 6. And we kept doing that until we used all 42 of these. It's going to put 7 per bag. Okay? So again, always remember, if it's asking you to package something or group something, if it's asking what is the greatest number that you can have, you're always going to be looking for the greatest common factor. And when you're looking for the greatest common factor, you're asking yourself, what times what is going to give me that number? Okay? And so that's where you're going to list them out, find the ones that they have in common, and then figure out which one of those ones is the greatest of the ones in common. Okay, and that's going to give you your answer. All right, so I'm going to post this. If you still have questions, feel free to email me. I'm also going to post it with a key back there. So if you want to look at the key after you have some of them worked out, feel free, double check your work. And then if you get stuck, please email me. All right, so what we're going to do now is we are going to look at least common multiple. Okay, if I can get my sheet. All right, here it is. Okay, and if you can hear, Maggie is in the background crying. So, all right, stay with me. All right, least common multiple. Remember I told you when we're dealing with least common multiple, you're going to see keywords like every, when will they both happen. Anytime you're looking for numbers that are going to overlap each other together. Most of the time in the form of a calendar or in the form of repetitive, like if you're counting. Remember we talked about multiples being like the song that doesn't end. They keep going and going and going and going and going and going and going. There is no stopping point. Okay, so let's look at this first one. It says Ned is training for a biathlon. He's going to swim every 6th day and he's going to bike every 8th day. Okay, well if he swims every 6th day and he bikes every 8th day, they want to know what days is he going to do both of them together. Okay, so that automatically tells us that we're looking for the least common multiple. All right, so you have 1, 2, 3, 4, 5, 6. He's going to swim. 7, 8, 9, 10, 11, 12. He's going to swim. 13, 14, 15, 16, 17, 18. He's going to swim. 19, 20, 21, 22, 23, 24. He's going to swim. Well, if he bikes every 8 days, 1, 2, 3, 4, 5, 6, 7, 8, he's going to bike. 9, 10, 11, 12, 13, 14, 15, 16, he's going to bike. 17, 18, 19, 20, 21, 22, 23, 24, he's going to bike. See how this is the first number that we come to that is a multiple of both? Well, that means every 24 days, he is going to do both swimming and biking, okay? And again, I told you, if you wanted to draw it out in a calendar where you made it and you count the number of days, you'll see that on the 24th day, that's where he's going to swim and bike, okay? Either way, if you want to draw it out, you want to list the multiples, as long as you get 24 for your answer and you understand that that's what that means, okay? And let's look at this next one. Okay, it says a store is holding a promotion. Here's that word again. Every third customer is going to get a free keychain. Every fourth customer is going to get a free magnet. They want to know which customer is going to be the first to walk in the door and get both a keychain and a magnet. Well, okay, so 1, 2, 3 comes in, gets a keychain. 4, 5, 6 gets a keychain. 7, 8, 9 gets a keychain. 10, 11, 12 gets a keychain. Okay, these are the customers that are going to get keychains. Well, if someone else is standing on the other side of the door while this person's handing out keychains, they're handing out magnets. So 1, 2, 3, 4 is going to get a magnet. 8 is going to get a magnet. 12 is going to get a magnet. Look at there. Lucky winner. Customer number 12 is going to get both. Okay. Let's look at this next one. Oh, look. Here. Calendar. All right. Kevin's going to water his ivy. Look, another word. Every third day. And he's going to water his cactus every 5th day. And they want to know which date is he going to water both plants. Okay. So you can either draw it out in a calendar. Okay. And I'm going to try to do this from the other side of my computer. All right, so every third day he's going to water his ivy. So we're going to say 1, 2, 3, ivy. 1, 2, 3, ivy. 1, 2, 3, ivy. Wait, 1, 2, 3, ivy. See, trying to do it from my computer. Okay. All right, here we go. 1, 2, 3, ivy. 1, 2, 3, ivy. 1, 2, ivy. 1, 2, 3, ivy. Okay. Now, draw that. Okay. Then he's going to water his cactus every 5 days. So we have 1, 2, 3, 4, 5 cactus. 1, 2, 3, 4, 5 cactus. 1, 2, 3, 4. Look right there. So this is the magic date. Well, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So on February 15th, he's going to do both. So you can either do it that way, or you can say, okay, well, if I'm counting by 3s and 5s, 3, 6, 9, 12, 15, 5, 10, 15. 15 is the first multiple that we come to that they both have in common. So that tells us that that is when he's going to water both plants. Okay, I'll do one more with you. And again, these are all going to be posted on the website. So feel free to print them out if you want and use them to practice. Okay, I'm not going to do this one with you. That is just listed out multiples of 5 and 150. And remember, the trick is if the higher number is a multiple of the smaller number, that higher number is automatically the least common multiple. Okay, because if we were to list the multiples of 5, we would start with 5. If we list the multiples of 150, we're starting with 150. Automatically, that's going to be the first one that you come to that is also in common with 5. So always keep that little reminder in your head as a helpful little tip. Okay, so let's look at Tia. Tia is buying paper cups and plates. Cups come in packages of 12. Okay, and then plates come in packages of 10. She wants to buy the same number of cups and plates. And here's that key part of the word problem. Since they come in different numbers per pack, that's telling us automatically we're going to have to find the least common multiple to see how many packs of this she's going to have to buy, how many packs of this she's going to have to buy to have the same number of both cups and plates. But she wants to buy the least. Again, here's that word the least number of packages possible. How much should Tia expect to pay if each package of cups is $3 and each package of plates is $5? Well, before we get to this complication down here, we need to find the least common multiple. Okay, so we're going to come over here to the side and we're going to say, okay, our cups come in packages of 12 and our plates come in packages of 10. Okay, this is our cups and this is our plates. All right, so if we're looking, this is one package. Well, if we buy another package, that gives us 24. If we buy another package, that gives us 36. If we buy another package, that gives us 48. And again, we're just counting by 12s. And then if we buy another package, that gives us 60. Well, automatically, I know I probably can stop right here because if I move to my plates, one package gives me 10, two packages gives me 20, three packages give me 30, 4 gives me 40, 5 gives me 50, 6 gives me 60. Okay, so there's our least common multiple. We know we need 60 cups and 60 plates, but they're wanting to know how many packages of each. Well, we need, and we'll count them, 1, 2, 3, 4, 5 packages of cups. Okay? Don't jump off the train. Stay with me. And then for plates, okay, we're going to write plates. We need 1, 2, 3, 4, 5, 6 packages. Okay? If I buy 5 packages of cups and 6 packages of plates, that's going to allow me to have the same number of each. Okay? Now here comes the complicated part. And it says, how much should Tia expect to pay if the cups cost $3 and the plates cost $5? Well, if we're buying 5 packages, 5 times $3 per package is going to give me $15 that I'm expecting to pay for the cups. Okay? And then my plates cost $5 per package. So I'm going to multiply that times the $5, and I'm going to expect to pay $30 for my plates. Okay? All right, so I'm going to, like I said, I'm going to post this. I'm going to post the greatest common factor one. Again, if you're dealing with word problems and they're asking you to group things or package things, or it's looking for the greatest of something, these are your greatest common factors, okay? If it's asking you when every so often will happen together or the least amount of something, that's your least common multiple. Okay, this is the number that's going to overlap each other because you're counting in increments of those numbers. This is where you're trying to find common grounds. You're taking a number of this and a number of this and you're making groups. Okay. All right, guys, so this is everything that I think will help you. Again, if you need more help, just shoot me an email. I will walk you through step by step on something that you need. Or, you know, send me a remind notice. I think y'all can message me through Remind. If you need my email address, it's brittany.acord@sb.org, livingstonparishschoolboard.org. Okay, so feel free to email me, shoot me a message on Remind if you still need some help. Use this to study. We will continue testing on Monday. Don't stress about it. Use this extra time to study. Even if you did finish your test, I'm going to give everybody their test back. That way you can look over it, make sure you're satisfied with it, and we'll go from there. All right, guys, have a good weekend.